Welcome to Teaching Statistical Thinking with Social Media. In this first video, we use examples from social media to help students understand how to visualize data in a single variable. Understanding these visuals will enable students to quickly characterize a set of data without examining the individual data values themselves. Histograms, box plots, and stem and leaf plots are the three one-variable graphics addressed in most high school curricula. Questions about these graphics are quite common on standardized tests. Since stem and leaf plots are often learned in early mathematics courses, we focus on only histograms and box plots in this course. In this first pedagogy video, I'll be sharing some helpful tips and mnemonics that will help your students remember some of the important terminology needed for these distributions. In the second video, I'll explain some fun activities that you can incorporate into your own lessons. For hard copies of all assignments and handouts, please see the resources section. As students begin to learn statistics, they are introduced to a variety of new terms: variable, histograms, and box plots, to name a few. For some students, these unfamiliar terms can distract them or even make them lose interest in statistics altogether. This video will share some helpful tips for how to create and analyze histograms and box plots in your own classroom. At the beginning of a statistics unit, you will need to introduce students to different types of variables. Keeping them straight can sometimes be difficult for students, and introducing a mnemonic device or explaining the variable types using topics students care about should help them remember the different types. For instance, take a look at this graphic on the screen. A numeric or quantitative variable answers the question how many or how much. Tell your students that the word quantum in Latin means how much. So when you're looking for a quantitative variable, you're looking for a number. The number of likes and followers on Facebook are numeric variables. A categorical or qualitative variable answers the questions what type or which category. Remind students that these variables are not numbers, but are instead categories of things. When thinking about social media, types of social media websites that you use, Twitter, Instagram, and YouTube, are all categorical variables. As a teacher, I often have my students think of the different categorical and quantitative variables that we could measure together as a class. Have your students think of their own variables. Histograms are often an intimidating concept for students beginning to learn statistics. Histograms are a type of bar chart that allows us to see the frequency distribution of a data set, or the counts of data. An easy way to remember why we use histograms is that when we study history, we learn about a lot of different counts, like Count Dracula. A box plot is a graphic that shows the 5 most important descriptive values for a data set. Often, just drawing a box helps students to remember what they need to find. When drawing box plots, it's helpful for students to have a list of steps to follow. I tell my students to first draw the x-axis, then find the median, next the lower and upper quartiles, then find the length of the whiskers, and finally decide if there are any outliers. When describing distributions, I use the mnemonic SOCKS to help my students remember to always describe the shape, the outliers, the center, and the spread of the distribution. Shape identifies the correct direction of skewedness, and it can be confusing, even for teachers. When looking at a skewed histogram, draw an arrow pointing in the direction of the histogram's tail. If your arrow points left, the histogram is skewed left. This works every time, but make sure students know that the reason a left-skewed histogram is left-skewed is because most data falls on the right, not because of the arrow they drew. The opposite is true for a right-skewed histogram. When viewing a box plot, it may seem more difficult to identify skewedness. However, if the left half of the box is significantly longer than the right, the distribution is skewed left. The most important thing for students to realize is that not every distribution has outliers. In histograms, If 2 or 3 small bars are separated far out from the rest of the bars by a wide gap, those data values can be labeled as outliers. In box plots, however, we use the formula quartiles plus and minus 1.5 times the inner quartile range to calculate the lowest and highest point of the 2 whiskers. Any data values that are beyond the whiskers are outliers because they are outside the whiskers. Mean and median are the 2 measures of center commonly used to describe distributions. The median is often easier to estimate from a histogram than the mean, so let's start with that. Have your students shade in exactly half of the histogram, starting from the left and working towards the right. The point at which they stop shading is the median. I like to describe the mean as the balance point of a seesaw. Let's imagine that each data statistic, or piece of data, is a toy block, and we stack our blocks up in a particular way to form a histogram. To estimate the mean, we have to slide our histogram along the seesaw so that it balances perfectly. I ask my students, if we set the histogram on a seesaw, where would the balance point be? Wherever the balance point falls on your scale is approximately the mean. To estimate the mean, you can also think about the quantity of small value and large value data. If there is significantly more small value data in the distribution, then the mean is pulled left of the median. If there is significantly more large value data, then the mean is pulled right of the median. There are 2 measures of spread commonly discussed in high school curricula. The first is standard deviation and is usually used with histograms. The second is the inner quartile range, used only with box plots. Standard deviation can be a confusing concept, but explaining it as the average distance to the mean is very helpful. Think, are most data points close to the mean of the data? Then the standard deviation is close to 0. If most data points are far from the mean of the data, then the standard deviation is far from 0. The inner quartile range, or IQR, is the measure of spread used with box plots. Specifically, the IQR is the length of the box. I've found that my students rarely have trouble remembering how to compute the IQR. When describing distributions, it is of great help to emphasize to students that their answers can be slightly different. Statistics is a relatively subjective field of mathematics, so students always need to justify their answers to be fully correct. This concludes Part 1 of Pedagogy Video 1. All materials are available in the Resources section. Thank you for watching.